Hello, class 12th physics, dual nature of radiation and matter chapter, important questions. An electron and an alpha particle have same de Broglie wavelength with them. How are their kinetic energy related to each other? So here few things we need to know about this question, like de Broglie wavelength lambda equal to h upon p is momentum, and in terms of kinetic energy it will be h upon root 2m kinetic energy. So they have same de Broglie wavelength, we know, but we also know that both of having different masses. And we also know that mass of alpha particle is much greater than mass of an electron. So here they have given that de Broglie wavelength of both alpha particle and electron are same. Lambda E is equal to lambda alpha. So it is h upon root 2 mass of alpha, mass of electron, and kinetic energy of electron is equal to h upon root 2 m alpha and kinetic energy of alpha. So h will get cancelled, root will also taken off, 2 will also get cancelled. So we will have this m actually subscript e, kinetic energy E is equal to m alpha kinetic energy alpha. So how their kinetic energy is related to each other? So if anything we can do, I can take me here in the denominator and this here. So kinetic energy of electron upon kinetic energy of alpha is equal to mass of alpha upon mass of electron. This is the relation, this is how they are related to each other. And also, as alpha is very greater than me, so we can say it is very greater than 1, or kinetic energy of electron is very greater than kinetic energy of alpha. So in such type of questions you need to follow the formula associated with it and put them into given condition. Like here they have given that both have same de Broglie wavelength. In contrast, if they would say that both have same kinetic energy, then we'll rearrange this formula, uh, write it in terms of kinetic energy, and then equate both of them. Or it can be in terms of momentum also. So here we can rearrange it for momentum and then equate both of them. So such type of question can be handled like this. All right, next, two lines AB in plot given below show the variation. Alright, next question. Two lines AB in the plot given below show the variation of de Broglie wavelength lambda versus 1 upon root V. So this is something tricky. We know the formula um, uh, lambda equal to h by p, and then it is h by root 2 mk, and ke actually kinetic energy, and then for charged particle it is 2m qv. So from here we can say that lambda and some constant and then 1 upon root v. So we can write lambda directly proportional to 1 upon root v. So if we take 1 upon root v as a single term, as a single quantity, so both are in direct proportion, both are indirectly proportional to each other. So where V is accelerating potential, we know. Two particle carrying same charge means this term Q is same for both. Which of two represent particle of smaller mass? So this is a bit tricky question, and so what I am explaining here, we have to explain it this way. H by P, so H by root 2m ke, and for charge particle H upon root 2m q v, and then H upon root 2m q 1 upon root v. It means the slope of lambda versus 1 upon root v is equal to h by root 2mq. Actually, its slope between the graph of lambda and 1 upon root v is h upon 2mq. This is how we find the slope. How? Because if this is the graph, its slope will be perpendicular, which is the value of lambda, upon base, which is the value of 1 upon root v. Perpendicular upon base, perpendicular from here, which is lambda, and base from here. So this is perpendicular upon base. We have to put it in the denominator. So what will be the left? This is the leftover. And out of this charge, if they have given that both have same charge, so means mass is responsible. So slope is directly proportional to 1 upon root of mass here, because h Planck constant 2 is number, q given same charge. So what left? Mass is left. So 1 upon root m. It means the graph which will have less slope will represent greater mass, and which has more slope will represent more mass. Since slope of they have asked for smaller. Okay, it doesn't matter. Slope of B is greater than slope of A, then according to this, we can say mass of B is less than mass of A. So which is representing smaller mass? B is representing smaller mass. Okay, next the figure shows plot of three curves ABC showing variation of photocurrent versus collector plate potential for three different intensity I1, I2, I3 having frequency nu1, nu2, nu3 respectively incident on photosensitive surface. So these are given accordingly. Point out two curves for which incident radiation have same frequency but different intensity. So stopping potential depends upon frequency, and saturation current, you need to write it completely. I'm using symbol, you can write it completely. Stopping potential depends upon frequency only, and saturation current depends upon intensity. Here these I1, I2, I3, and these are not current, these are intensities. So now Point out two curves for which incident radiation have same frequency but different. So all of them have different intensity, no doubt about it, but same frequency. Since A and B has same V naught, so both corresponds to same frequency. And different intensity, as IS is different. That's all. Actually, there are some orientational problems. That is why you can see there are some slantness, but I will make sure that you would be able to understand it better. The stopping potential of an experiment on photoelectric effect is 1.5. What is the maximum kinetic energy? Wow, that's a very nice question. Actually, this type of question can be answered directly. So, but I will elaborate that. So, first you can write direct answer. Kinetic energy max equal to, it is 1.5. So 1.5 electron volt. That's all. That's it. Or else if you want to explain it, then you can write Ke max equal to charge into voltage. Stopping potential charge is E into 1.5 volt, which is 1.5 electron volt. That's all. If they would ask to find it in joules, then you can put value of E also. The maximum kinetic energy of photoelectron is 3 electron volt. What is stopping potential? Now we can do it in a reverse manner. Kinetic energy max is equal to charge into V naught. So kinetic energy is given 3 electron volt. Charge is E, V naught. E will get cancelled. V naught equal to 3 volt. Show graphically variation of lambda versus V through which electron accelerated from rest. Okay, so first we need to find what is the relation between lambda and V. So lambda equal to h upon p, so h upon root 2 m kinetic energy, so h upon root 2 m q v. So it is in inverse proportion, and that's true with half of the power because of root. So if we could draw graph between V and lambda, that will be a schematic graph, not an exact graph. So this will be like a typical inverse proportion curve. Neither it touch this axis nor this axis. So not to be confused with this question where the graph was between lambda and 1 upon root V. So it was direct proportion, 1 upon root V, entire single term. Instead of this, if you could put single variable, let us suppose x, so x is direct proportional, but here it is in inverse proportional, because if we are focusing on V, so it is inverse proportional. That is why this curve will go in the form of a typical inverse proportional curve. Define stopping potential in terms of photoelectric effect. So the minimum negative potential at collector plate in photoelectric effect experiment, at which you need not to follow this pattern, you need to write it in full. So in photoelectric effect experiment, at which photocurrent becomes zero, is called stopping potential. Stopping potential or cutoff potential. State de Broglie hypothesis. State de Broglie hypothesis. Radiations and moving objects both behave as particle as well as wave. So there is a matter wave associated with each moving object. Actually, this much is enough. This is just to elaborate that thing. That's all. A proton and an electron have same kinetic. Now, initially there was a question. It is quite related to that also. So, have same kinetic energy. Which one has greater wavelength and why? So, once again, we can use direct relation. So, we know that lambda equal to h by p. So, that is why h by root 2m ke. They are saying that both have same kinetic energy. I'm squaring both, and so actually, well, it is not in fact required, but still I'm doing that. Lambda square equal to h square upon 2m ke. So ke is equal to h square upon 2m lambda square. Both have same kinetic energy, means kinetic energy of proton is equal to kinetic energy of electron. So it means h square by 2 mass of proton lambda proton square is equal to h square by 2m mass electron lambda electron square. These will get cancelled, these will get cancelled, both are in equality. So m p lambda p square equal to m e lambda e square. Okay, so take it in the denominator. mp upon me equal to lambda e square upon lambda p square. We know that p is greater than e, very very greater than, in fact. So mp is very very greater than me. So mp upon me is very very greater than 1. So it means lambda e square upon lambda p square is very very greater than 1. So it means lambda e square is very very greater than lambda p square. So lambda E is very greater than lambda T. Define intensity of radiation in photon picture of light. A casual definition, just the word meaning type. Intensity is equal to is the number of photons is proportional to the number of photons incident. But that is not scientific. You might get marks for this definition. Actual definition is somewhat required bit more formalities. So it is number of photons incident per unit area per unit time is called intensity of radiation. So it is better to leave all the exception. Number of photons, that is must. Per unit area, per unit time. Next, why photoelectric emission not possible at all frequencies? So clear answer according to Einstein's equation. H nu minus nu naught is equal to Ke max. If nu is less than nu naught, then according to equation Ke max equal to negative, which is not possible. Or if you want some more theoretical answer, then you have to write it like as it must required, metals must required actually photoelectron must required some energy to overcome their work function. So at any frequency it is not possible. It is possible above threshold frequency and all that. But instead, if you want to prevent yourself writing all of this, you can just use this equation and that's all. Okay, write the expression for de Broglie wavelength associated with the charged particle having charge. Alright, we have done it many times. Lambda equal to h by p, and this can also be written as root 2 m kinetic energy, and we know that kinetic energy is if a particle is accelerated, charged particle accelerated with potential v, then it is 2m qv. We can explain it like this: v equal to w upon q. So here it is equal to kinetic energy upon q. So kinetic energy equal to qv. That's all. Draw a graph between photoelectric current with intensity of radiation. We know that photoelectric current, actually it must be saturation current, but if it is given casually like this, then okay, graph between photoelectric current with intensity. So only intensity is asked, so here intensity and here photocurrent, actually such saturation photocurrent, then both are directly proportional to each other. Find the ratio between de Broglie wavelength associated with two electrons accelerated through 25 and 36 volt. Alright, so two electrons are there, lambda 1 upon lambda 2, that is, we know lambda is equal to, from this formula, h upon root 2 m, charge is ev. So for both h and all these things will be same. H is lambda is inversely proportional to v, so we can write it is root v2 upon root v1. So 36 upon 25, that is 6:5. Next graph shows variation of stopping potential with frequency of two photosensitive material AB. Which one has higher work function? Justify. So according to photoelectric equation, we can use Einstein's photoelectric equation by Einstein's photoelectric equation, H nu minus nu naught, equal to EV naught. So see here, little bit mathematics is required for straight line graph. For straight line in maths, if it looks like this, the equation is, this is x, this is y, equation is y equal to mx minus c. So in the same way, this will be in the form of v naught equal to h by e nu. I have rearranged it, I have put it into denominator, open the bracket, so I have done it, and it is h nu naught by e. So we can say that it is h by e nu minus phi by e. So now which one has higher work function? Oh, actually this much, even this much is not required. We can find it from here, or we can find it from here, which has greater this value. So we can easily compare it from the graph. But also we can say, kindly ignore this thing. Sometimes we try to be more tricky, but there are some other tricks for that. We know that nu naught dash is greater than nu naught, so phi dash is greater than phi. That's it. Justification: since phi equal to h nu naught, phi dash equal to h nu naught dash. In fact, we could do it with the help of this also. So here this will be a long process, and see, they are asking about work function. So from here we can say intercept of, directly with the use of graph, we can say intercept of A is more in magnitude than intercept of B. So that is why phi dash is greater than phi. By observation, we can say. So they have asked which has higher work function. So A has higher work function. Okay, next. Actually, once again, I apologize for that orientational error, but sometimes we have to go with this. This is what physics all about: shifting of coordinates. An electron is revolving around nucleus with constant speed. This one, find the Broglie wavelength associated with it. Okay, more and more calculations are there. So h equal to, oh sorry, what is this happening? Twice I think I did. H by p. So this is h by p means h by mv. So 6.62 or 3, whatever be given there, into 10 to the power minus 34 upon mass of electron 9.1 into 10 to the power minus 31 into velocity 2.2 into 10 to the power 8. So it is approximately 3 and 3 3s are, so 1 by 3, approximately 1 by 3 into 10 to the power minus 34 plus 31 minus 8. So yeah, of course, so it is 42 minus 42 plus 31 minus 11, so it is 0.33 into 10 to the power minus 11 meter, or 3.3 into 10 to the power, this value increase, so put one minus here, or one more minus. So this is what is it is. Draw a plot showing variation of de Broglie wavelength with kinetic energy. Oh, so of course we have done it several times. H by mv, which is h by p, and oh, what I'm doing, I'm messing with all of it. So it is 1 by root 2 m kinetic energy. So it means lambda is inversely proportional to root of kinetic energy, whatever it is. Whenever inverse proportional graph is this there, so lambda. So inverse proportional graph is like this. Neither it touch this axis nor that axis. Name phenomena which shows quantum nature of electromagnetic radiation. So this is photoelectric effect. That's all, because only we know this only chapter here. State the reasons why wave theory does not explain photoelectric effect. All right, I had explained it in my video, but according to wave theory, intensity is proportional to amplitude square and related to and responsible for energy transfer. So it should relate with stopping potential, but experimentally V naught is independent of intensity. Wave theory also believed that photoelectric emission can take place at any frequency, but experimentally it was found that below threshold frequency photoelectric effect does not take place. Space, there is no space. I'll use an additional sheet for that, supplementary sheet you can say. There's another thing, frequency of light according to wave theory. Frequency of light is responsible for emission of number of photoelectrons, and hence photocurrent. But experimentally it was found that current depends upon intensity and not frequency. And final thing, wave theory predicts a time lag in the process. But it was found experimentally that it is an instantaneous process. That's all. If the distance between source of light and cathode of photocell is doubled. Cathode means that photosensitive surface is doubled. How does it affect stopping potential applied to photocell? Alright, so they have given a technical question here. Well, what they are asking, distance, we haven't studied anything related to that setup and distance and all that, but I can tell you, like if we glow a torch and if we set it into different positions, so intensity of light changes. So actually there is a formula for that also. Actually intensity of light is inversely proportional to square of distance. So if we increase the distance, intensity of light decreases rapidly. This is what happens when we zoom in, zoom out that torch. If we put it close to a wall, then that region glows brighter because intensity is more, and if we glow it from far distance, then it glows, that surface glows a little bit dimmer because decrease in intensity. So ultimately, with change in distance, the intensity of light will change, will decrease. Actually they have said that it is doubled with the change, not change, with increase in distance, the intensity of light will decrease. And as stopping potential is independent of intensity, so it will unchanged. So V naught remains unchanged. Alright, so next, an electron is accelerated through a potential difference of 100 volt. What is the de Broglie wavelength? Actually, there are mix up of these. De Broglie wavelength associated with it. To which part of electron? Oh, this is an additional part, but what about this? So see here, for lambda, for electron, there is something you need to memorize. This is what else you can do. Will you want to calculate? Yeah, go and calculate. This is something what you can do. Mass of electron, charge of electron, and V, and then you will get the answer, convert it into angstrom, and V will be remaining there like it is. Or you can just memorize this. So here 12.27 angstrom, I am writing it like this, upon 100 it will be 10, then this 10 will go up, it will become, oh, in fact it is not required. 12.27 into 10 to the power minus 10 upon 10, so it will be 1.227 into 10 to the power minus 10 meter. So this wavelength corresponds to, well, it is in the borderline, so but 1.22, actually it is in the borderline of 10 to the power minus 10. If we go to 10 to the power minus 9, there is UV region, and if we go this way we have X-ray. So alright, but it is 1.22 means it is more toward this, so it is in X-ray region of electromagnetic wave. An alpha particle and a proton are accelerated from rest by same potential. Find ratio of their de Broglie wavelength. Again and again, same type of question. So formula required is h upon accelerators same potential, 2mk ke root, and kinetic energy is qv. So their de Broglie wavelength ratio. So lambda of alpha upon lambda of proton is equal to, actually we can say, we can do it directly also. In terms of mass and kinetic energy, it's proportional to, because other things are constant. Mass of proton and alpha particle are different, that is why we have to take m and ke only, and h and 2 taken as constant, so lambda is proportional to this. So both are in inverse proportional. That is why, see, now see the trick. That is why I am going to write it like this: mass of proton, because it is in inverse proportion, and kinetic energy kinetic energy of proton upon mass of alpha and kinetic energy of alpha. Next thing, see, find the ratio. We have to find their ratio. So approximately, if one more thing we have to remember, that mass of proton, if mass of proton is m, so mass of alpha particle is 4m. So we'll put it here, m. Kinetic energy is qv, q of proton into v upon 4m into q of alpha into v. V are same, mm will also get cancelled. Another, again, qp is e and q alpha is 2e, because alpha particle we know it contains 2 protons, so mm is also get cancelled. So in the numerator there is e proton, so e upon, in the denominator there is 4 into this 2e, so it will be 1 by root 8, which is 1 by 2 root 2. That's all. They have asked for ratio, so this is the ratio, 1:2 root 2. Quite unusual ratio. Write Einstein's photoelectric equation. State clearly the 3 salient features observed in photoelectric effect, which can be explained on the basis of above equation. So we have to write Einstein's equation, and see, I'm using this, E equal to the energy of photon. We have to explain what we are writing: phi work function and plus kinetic energy maximum. Also, this can further be written as kinetic energy max equal to h nu minus phi. You know why is it so, and also h nu minus nu naught. So now the salient features observed in photoelectric effect. So from here, first thing we can draw that photoelectric emission cannot take place for frequency less than nu naught. Otherwise, kinetic energy becomes negative, which is not possible. First thing. Second thing, one more thing. That is equal to EV naught also. So I have done everything here in this equation. Second thing, stopping potential V naught depends upon frequency of radiation only. That's it. It depends upon frequency. We can see it from this equation. And third thing, stopping potential is independent of intensity of light, of radiation, as there is no intensity term in the equation. That's all. Okay, plot a graph showing variation of stopping potential with frequency of incident radiation for two different photosensitive material of work function, two different work function, W1 is greater than W2. On what factor does slope intercept depend? So nu with the frequency. Okay, so this is V naught, this is nu. W1 is greater than W2. What we used to write phi, they have written W1 and W2. So if W1 is greater than W2, since W1 is greater than W2, so W1 will be H nu naught 1 is greater than H nu naught 2. So nu naught 1 is greater than nu naught 2. So here this is nu naught 1, and here it is nu naught 2. These are two things, and see, remember, both will have same slope, so they will be parallel lines, and these are their intercept. Few moments ago there was a problem in which the same question was in reverse order. So here it is phi 2 by E. Why is it so? I will let you know later on. Minus phi 1, oh god, upon E. Alright, so it is because we know that photoelectric equation is Ke max equal to H nu minus H nu naught, and Ke max is E V naught equal to H nu. In fact, instead of writing H nu naught, I am writing phi. It should be written like this. So this will be upon E minus phi upon E. Now comparing it with equation of line y equal to mx minus c. Especially I am writing minus c because for negative intercept, that is why I am writing minus c. Otherwise we can put plus c, that doesn't matter. Means at that time value of c is a constant. At that time value of c is negative. So it is very much clear. So now on what factor does slope? So slope is equal to h by e. So slope is equal to h by e. If we compare both of them, m is slope, so slope is h by e, which is independent of material. Whereas intercept, this is the first part, and the second part is about intercept. So intercept depends upon work function. Intercept, I'm writing c, depends upon work function. Oh, sorry, they have given w, so we have to put w. So much kata pt is there. Anyway, so c depends upon work function. Oh, that's all. They haven't asked anything else here. All right, so next. I don't know whether this much amount of space is required for this question or not, but okay, let's see. A proton and a deuteron. Oh, what is deuteron then? Proton mass of proton is m, charge of proton is E. Deuteron actually, you know that 1h2, deuterium. So what is deuterium? If we remove electron from deuterium, then what is deuterium? It has one proton and one neutron. That is why a deuteron, mass of deuteron is twice that of mass of proton. But charge of deuteron is equal to E because it has one proton. So a proton and a deuteron. Okay, what I did? Oh, sorry. This is part 1 and this is part 2. A proton and deuteron, other is proton and alpha particle. So I'll write specification for alpha. Mass of alpha particle is 4m because it contains 2 proton and 2 neutrons, and charge of alpha particle is 2e. Okay, so this is part 1 for proton and deuteron, and this is part 2 for proton and alpha particle. Same accelerating potential, which two has greater wavelength, less momentum. All right, so greater wavelength, less momentum. So the particle which will have greater momentum, greater wavelength, will have less momentum according to equation lambda equal to h by p. So the answer of this will be the answer of this. So there's no problem with that. So the problem is how to find lambda then. Actually, this is the question to compare lambda. And again, same type of question is coming. Same accelerating potential. We have to find ratio between their wavelength. So we know lambda equal to h by, now I'm directly writing this thing, 2mqv. Be careful about it. Now h will see now mqv, these three terms should be taken care. And now lambda, see carefully, lambda p upon lambda d, proton by deuteron, is equal to root of mass of deuteron, charge of deuteron v, upon mass of alpha, mass of proton, charge of proton into v. We will get cancelled. Mass of deuteron 2m, charge of deuteron E, mass of proton m, charge of proton E, root 2. So lambda p by lambda d is equal to root 2. Root 2, that is greater than 1. Root 2 is greater than 1. So it means lambda p is greater than lambda d. And as this is the answer to first part, and as lambda is h by p, therefore p of proton is less than p of deuteron. Oh, sorry. Yeah. Okay, so they have asked which has am I doing some error here? Okay, they are asking about less momentum. So which has less momentum? Which has greater wavelength? Proton. Which has less momentum? Proton. Both answer. So I should not write A here. I should write A here. Answer of A is proton. Answer of B still proton. In the same way here. I'm doing it directly. Lambda p by lambda alpha is equal to mass of alpha. Well, student, you can pause the video and try it of your own. And you can then cross check it, see whether you people are doing some error in it or not, or are you doing it comfortably. So lambda proton upon lambda alpha is equal to root of 8, which is greater than 1. Rest of thing same. Next, monochromatic light. Monochromatic means single color, means single frequency. So not to be confused with this word. Produced by laser. Oh, this watt, it is power given. This is power. Estimate number of photons emitted per second. Now there are some technicality in this question, but it is not that tough as we are thinking it. Power equal to energy upon time. Work upon time, but more generally energy upon time. And energy is number nh nu upon t. So they have asked that number of photon emitted per second. P is given 2 into 10 to the power minus 3. Nu is given 6 into 10 to the power 14 watt hertz. T is given per second, 1 second. Put the values here. H we know. So I think I have to do Alright, so N equal to Pt upon h nu. So Pe 10 to the power minus 3, T is 1, h 6.62 into 10 to the power minus 34 into nu 6 into 10 to the power 14. Now I have to come here. Remember, multiplication of both of them is close to 40. Just remember this thing. It is close to 40. And don't show this calculation in the exam. Oh, sorry, 40 it is. 40 into 10 to the power minus 3 plus 34 minus 14. I think we are going on right track. It will be 1 upon 20 into 10 to the power, it is 2017, or we can say 100 upon 20 into 10 to the power 15. So answer is 5 into 10 to the power 15. 15. Okay, now so next, using the graph shown, calculate Planck constant. So see, most of you will say that we know the value and we can put 6.6 into that. But no, here you will find different value. So from this graph, what will you do is, you know this equation, V naught equal to h by E nu minus h nu naught by E. We have done it several times, so I'm not going to explain why is it so. And from here, h by E nu minus nu naught. So h is equal to EV naught upon nu minus nu naught. We know it is 1.6 into 10 to the power minus 19. From this triangle, V naught is 1.23 upon nu minus nu naught. These two values, 8 minus 5, and into 10 to the power 14 mentioned here. So it is 1.6 into 1.23 upon 3 into 10 to the power minus 19 minus 14. 3 5s are 15. This I'm doing approximate calculation. It is 0.5, and 0.5 into 123 is something above 6. Okay, we have to give the value up to 2 correct decimal places. So this time no approximate calculation. In fact, I can cut here. So it will be 0.41, and we can multiply both of them. This one into 10 to the power minus 33, or it is 6.56 into 10 to the power minus 34 joule second. So many times this question can be extended, like do further calculation for so and so, then you have to use this value, not the standard value.